Thanks, Jerome. Thanks for everybody for attending. I hope you enjoy today's presentation. This is a presentation about some recent research that we have completed. And so we'll give you an overview of that and the implications. Jerome's going to have to change the slides for us because for some reason the button that says sharing my screen did not crop up. So Jerome, you can change the slides and we'll deal with the delay. We put it down to the difference in daylight saving. The first thing I'd like to just say is that the results of this research that I'm about to talk about and share with you over the next 40 minutes or so, there is a report that is publicly available. It's available at the link that you see written up there, which is just simply at Griffith University under my name, and it's under a section called Griffith Experts, and it's a bit of a website that has our outputs and research papers and things. So the report cover looks like what you see there, and feel free to use, if you download it, it's downloadable in a PDF format, so you're most welcome to download it. All that we ask is if you use any information out of it in the future or you refer to it, you can see on this slide we've provided how we would like it referenced. So Jerome? In the first instance, before we get into it, I'd just like to acknowledge a few key organisations and entities. So firstly, the Motor Accident Insurance Commission. So the Motor Accident Insurance Commission funded this research and thought that it was a good opportunity to explore and investigate a pilot study associated with in-cabin technology. We also want to acknowledge the Queensland Trucking Association. They played a key role in this project, especially with recruitment and support and getting on board the 11 participating organisations. So we'd like to thank those organisations. You will see in this presentation and the report, the organisations are not named. It has been de-identified so that we can release the results publicly, but those organisations certainly know who they are, and we'd like to thank the key personnel involved with those organisations that helped out. It was a substantial bit of resourcing that they needed to do, and a bit of a lot of people's time, and along with the participation of the drivers. We'd also like to acknowledge the support of the two in-cabin technology providers. So they were the ones that provided the data, etc., associated with this. Jerome? So the aim of this research in the first instance was to undertake a pilot study to provide insight in and determine the effectiveness of some in-cabin technology. It was designed to reduce or identify driver distraction, inattention and fatigue, and try and see if the technology would reduce that. Instead of it being in a laboratory or a simulator, this was in a real world heavy transport operation. So while they were undertaking their normal transport and logistics in the normal part of their working days. Jerome? So just an overview of what we actually sort of did in terms of some of the methodology and process associated with this. So there was the QTA undertook the recruitment process and offered invitations out to various organisations in their network with the transport and logistics sector to come on board. They were provided with some pieces of the technology and for the participation and the pilot of this process. Some of the organisations also were implementing some of the technology in themselves with their own vehicles as well. So we had a few of those. There was a process associated with the installation of the technology and onboarding. So the technology providers installed the technology. They went out and did that and conducted an onboarding process about that, which was fairly consistent across the organisations, and we documented that process. The collection of the in-vehicle data, we undertook it for a couple of months first and sorted out a few bugs and things like that, as you do when you implement any technology in a working environment. And we collected the data across these 11 organisations for a period of 8 months. So that was provided to us. We did also a before and after survey with drivers and stakeholders. The drivers did the survey, and then we did some stakeholder interviews as well. We conducted a brief organisational driving safety systems analysis. So that was looking at policies and procedures and things like that that were within the organisation and the processes behind supporting the safety and the fatigue and distraction. We also participated in a number of Queensland Trucking Association stakeholder working group meetings, so the project meetings and bi-monthly meetings there, and also an industry participation to disseminate some of this information and share things at progress as it was going along the way with the Yarn in the Yard initiative. Go again. Yep. So just to give a quick overview, a lot of you are probably familiar with the type of technology. The in-cabin sensors, it tracks the driver's face, eyes, head movements, determines eyelid closures, blink rates, and head positions. The sensors measure the head movements and eye closure. There's a predetermined safety level that the technology providers have set up, and safety level breaches are determined to be either fatigue or distraction. And when either of those two events are detected by the technology, a particular alarm or alert within the cabin is signaled. So what happens if it is a distraction event, an audio alarm sounds, if it is detected by the technology as a fatigue event, not only does an alarm sound, but the seat vibration also occurs. The data is then sent immediately to a 24-hour, 7-day-a-week operations centre for a secondary verification process. I won't go into the further details about that because it'll come to light a little bit later on. Jerome? So the types of events we mentioned before, there were distraction events. So there was set parameters that the technology providers have previously set up. So if the head position was not forward facing for a period of 4 seconds and the vehicle is traveling at 40 kilometers an hour or faster, that results in the audio alert. The fatigue alert is when the driver's eyes close for a period of 1.5 seconds while the vehicle is traveling 10 kilometers an hour or faster, and that results in both an audio and a vibration alert. There's the opportunity for the drivers to manually record events. If an incident occurs, they can press a button on the in-cab sensor and then 30 seconds of video footage is recorded. And there are also field of view exceptions. So if the in-cabin system is unable to detect the features, the facial features of the driver for a period of 10 minutes or longer while the vehicle is traveling at 10 kilometers an hour, then the in-cab sensor indicates a field of view exception, and the event is notified to the organisation or the stakeholder involved in that. That can happen. A field of view can be things like, if there can be a fault in the systems, that there's a connection problem. It can be things like drivers or somebody knocking things out of perspective, out of alignment, or covering cameras or whatever with hats or things like that. So that's when an alert comes through to the home base about that. Jerome? So we did the before and the after survey with drivers, and what I've summarised here is I'm providing just a few of the results, and the same with the technology. The report provides quite a bit of detail, but due to limited time, we haven't got all of that. But we were very interested to see the perception of drivers, whether the new technology alerts have been annoying. And if you just, looking across the the graph there. At the start of the project, you can see that, there's a lot of nearly all the time, and it's quite annoying. Towards the end of the project, or at the end of the conclusion of the project, the driver's perceptions were not so much towards the nearly all the time, more towards, occasionally. Jerome? We also asked a question around whether the technology alerts, if drivers felt that it helped them to drive safely. And you can see at the start of the project, pretty much the drivers' perceptions were at the end of the technology didn't really help them drive safely. Towards at the end of the project, there was more driver indications of frequently and nearly all the time. Now, there are some limitations associated with this data in regards to, obviously, it's a self-report before and after situation. One of the things that could be impacting there is a possibility is, people in a driving situation don't necessarily want to admit that they might be driving unsafe, or that they're not driving safely. So that can impact upon some of the results. But I think that that's encouraging, that at the conclusion of the project, people think that the technology was a little bit helpful. Next one. Oh. Jerome, can you change that one? Thank you. Just a bit slow. We also looked at whether, asking driver perceptions, whether the new technology alerts, whether they felt they were unnecessary. And you can see there that the change from before at the start of the project, conclusion of the project, is that drivers moved a little bit more towards the frequently, that the alerts were unnecessary. That information there probably backs up a little bit of the information I'll talk about when we get to the actual data itself. Jerome? Okay, and then the other question that we sort of asked, which we thought was interesting with some of the results, is with the drivers, if it was their decision, would they choose to continue to have the technology in the vehicle? And the reality is here, the perceptions to that are pretty polarized. You either really like the technology, or you really don't like the technology. There's not a lot in between. And that's probably indicative of a lot of technology within the workplace. People are either really passionate about it, or they absolutely hate it. There's not a lot of in-between ground. Jerome?
On that, Darren,
that's just on the survey part. And we're just wondering, we'll just take a pause there for a minute and see if there's any questions.
There's no questions
in the chat that I can see.
No questions at the moment, Darren. I was just sort of wondering, when you're touching on earlier and how people changed over time, do you think it's probably because they were really...
sound.
Oh.
Okay. It's a long delay. I can see, Nick, you've got a question in there. That's good. I can read them. So, did the drivers indicate privacy concerns? What we found initially is, in the initial instance, there was some drivers that were fearful of, I suppose, the Big Brother approach. Others were kind of like, oh, we're happy to give things a try if it might make a difference. So again, it was a bit of either love it or hate it. But one of the things that probably did come out of this is the importance of good communication, onboarding processes, and being very clear about what this is aiming to do, etc. The reality was, in terms of Big Brother approach, so to speak, is there's not a lot of big brotherness in it, in the sense that, you know, a person, if there's a video thing, will often think that people are just looking for everything that they're doing. The reality is that they're not. They tend to look at that video when an event occurs. So the event occurs and then the video footage came out. And in some cases, the video footage provided evidence, which you'll see shortly, that it was a false reading with the technology. It wasn't a safety alert event that it had indicated. So, you know, there's fors and against. So, yeah.
Darren, there's a question from Ron Shanks.
Was there a correlation between age and results? Look, there's some information about the age side of things in the report. One of the things that we have to take on board here is that this was not a huge sample. Jerome, can you type it in the chat, because your delay is huge, and I can run through the questions as they are in the chat. Okay, hang on. I'll just get to where was there. So I was up to where's the correlation between age and results. So we probably didn't have a huge enough widespread of sample to indicate that, because again, this was only a pilot project. So you know, of the 11 organisations, some of them only had between 2 or 8 pieces of technology in their vehicles, or vehicles with that number of vehicles in the scheme of things. Some of them had more, but you know, if we were to have taken this further, we would certainly look more towards that. The responses don't surprise me. Backs up, yes. Agree there. Given how long it take a driver to realise there's been an incident, do you think the manual recording 15 seconds? I think, Greg, I think in that case, it seems to be with, you know, the video type dash cams things, etc. Is that enough? I think that's an experiment that should be done. One of the things that we often find is that the time frames and or parameters are often set by technology providers, and sometimes there's not science behind it. So I think that's something we could do in future. How long was the data collection period? It was 8 months, and I've got numbers on the data shortly. We'll get to that in a moment. Did the drivers have previous experience? Look, some of them did, some of them didn't. The majority of participants that were involved had not experienced it before. So, yep. Not asking a question. Yep. How extensive was the change management exercise? Okay. Can I answer that a little bit later, in the sense that there was an onboarding process and it did consist of more than one session, but the results of what you're about to see shortly will have some significant implications actually for that question. In some instances, the video was shared with drivers. At times, if an event occurred, you might have a driver that went, no, I didn't fall asleep, or I didn't. And in some instances, sharing of that information, having a discussion with the driver would show the evidence and then maybe change that. But that was what happened with the video recordings, and the discussion with drivers was not within the scope of our component of the research. That was done by each of the companies and their fleet coordinator or safety person who was involved. Possibly, yes, Scott, that's possible. And I think over time, yes, people's perceptions and the way that they their attitudes towards it could change. Absolutely. I think the interesting thing about this, which you'll see shortly, is, and it's only a very glossed over perspective of some of the key results, which has some implications. And when we get to the implications, I think that's that's the time that you'll see, and we can engage in a pretty good discussion there. Yeah. Good. All right. So if you want to change to the next slide, Jerome. Thanks very much for the questions. It was really good. And I appreciate all of that. And appreciate your interest. Look, we also conducted stakeholder interviews. So this was not only, just the drivers, but also, I'm going to refer to it as fleet coordinators, etc. No, that was without a scope. Ron, we did not monitor drug use during the trial. That was outside of the scope of this project. But interestingly, there's a number of benefits and challenges associated with the technology, and I'll talk more about this in the next couple of slides. But one of the challenges associated with it is the onboarding and the installation of technology. Now, when I say this, I'm in the installation, the issues with installation. This is not picking on this particular type of technology. What's occurred here is very similar with any technology, whether it's your computer in your workplace or some technology fitted to a vehicle. The thing with everything in our workplace associated with technology is technology has times when it doesn't work, whether that's starting your vehicle, booting your computer. Today's Zoom event, Jerome, is an example. Technology is a tool, and it does have faults. So like all technology, one of the things that stakeholders do need to consider is the implications of the technology and the processes associated with when it doesn't work. What are we doing? How are we going to do that? Now, one of the concerns in the transport logistics sector, of course, is if you put technology into the vehicles and then the technology needs some maintenance procedures, it's a perplexing situation where you need to pull the vehicle off the off-road for a period of time to fix the technology. And there's challenges, with pulling a vehicle off the road for a set determined amount of time. There's also technology of coordinating that maintenance process around the work processes and the transport processes, and those processes of maintenance associated with any provider that's providing those to probably more than one company. So there's that. The other side of that is the onboarding process needs to be really thorough, and we worked a lot with the providers to ensure as best we could that the onboarding process was consistent. That was for the research, so that we could run some comparisons and sort of rule out that there were differences happening due to different onboarding. But what I say to organisations, don't underestimate the processes and the planning that needs to go into that. There's also, educating people about the use of the technology, the alerts provided by the technology, the different alerts, and you'll see shortly the implications of that associated with some of the results. There's also some challenges associated with, and I talk about this in more detail right near the very end, about the policies and procedures associated with managing the alerts. The reality is, if you put technology in the vehicles, you are going to get a lot of data. You are going to get, whether it's this type of technology or other technology, you are going to get data coming in that's going to tell a story. And we need to be very mindful of how much data that is, the resources involved in monitoring and doing something and managing the outcomes associated with that. And there's some benefits and challenges associated with the driver behaviour. So, we've got some evidence which is more in depth in the report of driver behaviour change, but in anything, we need to be mindful that the behaviour change that we want may not necessarily occur. We could have other change. So an example is, driver behaviour change. If you want to put in a new initiative, you're expecting a certain change to occur because of the initiative. And sometimes that can be a different type of behaviour change in figuring out the parameters, in figuring out to use the words, gaming the systems and processes. So we do need to be mindful of planning what the anticipated behaviour change is and what changes can actually occur that we may not have expected. Jerome, you could go to the next ones. So look, some key advantages that were reported from this. The implementation of the technology, some stakeholders reported that it was helpful in shifting customer delivery expectations. So they were able to provide information, better quality information about where vehicles were and what was happening and those sorts of things. So they said that helped. It appeared to help get customers understand of delays that were occurring. And for some instances, the presence of the technology was a selling point towards, these are the types of safety initiatives that we're putting into place. Organisations, some of them did see the value of recording the fatigue and distraction events, and in particular, they mentioned that some of this data was quite helpful in having conversations with drivers. And I used that example before where you might have for example, a fatigue event that happens and a driver may not think that has occurred. And you can show the video footage and then have a conversation around that and look towards more of the things that were occurring behind the scenes and how did that occur. Did any of the drivers, as a result of the detected event, result in a health referral to a GP? One of the things that sort of was parallel to this, but again, it was outside the scope of this, was there was a number of initiatives with free health checks offered across lots of the companies that participated, and it was a free initiative by the Heart Foundation. There were also some instances of drivers going to their GP, or being their line manager or whatever, indicating that needed to be. As to the numbers, I can't tell you because that was more a confidentiality issue we had to avoid in terms of ethics. With the drivers line haul or metro, they were both. There was a mixture of both. So although there's a lot of positivity towards the technology, however, some organisations did express that in terms of the cost benefit, the challenges the technology presents may not be worth having the technology. Now that differed across the board, across various organisations. Jerome, if you can go to the next slide, please. Now the challenges, look, and you'll see the numbers for this in a moment in my next slides. The biggest key challenges in this was the high rate of false positives. That was the technology was picking up indications or breaches of the parameters that they'd set up associated with distraction and fatigue, and the alerts went off in the cabin, and then the secondary process indicated that that was not the case. It was not a genuine event. And look, to give an example, that there's many parameters around this, but to just give an example, if a driver is driving towards the sunlight and probably was squinting, that has a possibility of indicating an alert that the driver may be falling asleep, when in actual fact they weren't. So there's many more, but that's just an example. The key challenge behaviour, there was some behaviour change, but when you look at the false positives associated with the data that we collated, then the behaviour change is not necessarily always positive, and or the change that you probably want. Yes, in the initial instance, there was driver pushback. There was that big brother approach. It appeared not to be as much as people become on board. And I think that highlighted if you're going to put any change in any of your transport sector, whether it's technology or otherwise, you really need to have that open line of communication and provide education and information around it and what it's anticipated the outcomes are going to be. Across the organisations, there were multiple instances of drivers resigning over the implementation of the technology. However, one of the points that we made in the report with this is that might suggest that the implementation of technology might result in unsafe drivers resigning, but the evidence indicates that that's not actually necessarily the case here. So people that resign are not necessarily going to be the unsafe drivers. If you put it in, you just may get some resignations. There were delays in returning emails and phone calls after an event occurred, and this is a key challenge that I talk more at the end of the presentation here. This has some significant impacts upon and ramifications for an organisation. If you're getting, if you have under-resourced this, you're going to get a lot of alerts coming through that have to be dealt with, whether they're false positives or whether they're genuine. And you need to have a process about that. You need to have people on board. You certainly can't have alerts coming in, at 10 o'clock on a Monday morning and you're not dealing with it until, later in the afternoon or the next day. There is challenges, as there is always, with technology and malfunctioning. There is the other challenge associated with this, with the technology, is whether the organisation can be fatigue focused or distraction focused, and there's a bit of a point with that. There's also some challenges associated with the lack of transparency and clarification about the secondary verification process. So the technology is provided by the technology providers. We were not privy to any algorithms or anything like that. That's their intellectual property. So, suspect not always, or more concerningly, due to potential fatigue state, may have dismissed the alert as just another false positive. Yes, there is some. I'm just going to say, before I get to the data, there is some issues associated with all of the recognition, and you'll see that in a moment, and you can take from that what you like. The other key challenge, as I mentioned before, with all technology is after sales service. If you've got vehicles that are operating a long way from a major, your major home base or whatever, and there are issues with the technology not working correctly and it needs some maintenance, then there are going to be challenges associated with that. You'll see that in a moment, Ron. I'm about to get to the next slide, and you'll see the numbers associated with that in the next slides. The technology that was used, the technology part of the project was that this technology was determined by the funders and other stakeholders, and the technology was available. I'm not going to mention the brands. There is plenty of technology, but because of the results and the way that this pans out, I'm not being specific about that. Jerome, can you go to the next slide and we'll get to some numbers associated with the technology. So we had 11 organisations participating. Each organisation had somewhere between 2 and 8 in-cabin technologies fitted to their vehicles. Some of the participating organisations had a few more, but the initial amount was that. But if you have a look at these numbers, of the total events over the 8-month period, you can see there's just over 287,000 events that were picked up by the technology. Of that total events across all 11 organisations over the course of the project, there was a 72% false positive rate. That is, the technology in the cabin is picking up an event as fatigue or distraction, and after verification is indicated that it actually was not a fatigue or distraction event. But the point to note with that is that within the cabin, when it's initially picked up, the alerts for distraction and fatigue go off in the cabin. So there are implications with the false positive rate that's obtained on such a high amount, but there were 78,000 verified events. Jerome, if you go to the next one, because I'll get through these data slides to get to the main points in a sec. To give you an indication here, you'll see of the distraction events. So in-cabin distraction events, you'll see here 12,000 odd distraction events detected. After the secondary verification process, you will see that then became 33,000 distraction events. Hold your questions for a moment. Jerome, if you go to the next slide, this will show the difference in those two numbers. There were in-cabin detected 23,000 odd verified in-cab detected events relating to fatigue. After the secondary verification process, you'll see that that dropped down to 2,800. So what's occurred there, if Jerome just momentarily flick back to the previous slide and then back to this one, what's happened here is that distraction events, the initial picking up of fatigue events, were later recategorized in the secondary verification process as distraction events. Now, what the key point here is demonstrating is that the technology does not have specific exclusive parameters associated with fatigue and distraction. There is obviously a bit of an overlap. So that's something we found quite interesting. But at the end of the day, there was still, of the 289,000 events that were recorded by the technology or picked up by the technology, of which 72% were false positives, there was still 2,820 fatigue events after that secondary process. Now, there was some, I can also tell you that there was, as an example, one event that we were able to interview the driver afterwards. It was and the technology definitely prevented a driver that had actually fallen asleep. Yes, in the report, we've got kilometres travelled and hours driven and things like that. I don't have that in front of me. I'm trying to do a sort of quick summary. Yep, the 2%. Does the technology, okay. There's some implications associated with the technology and artificial intelligence. Interestingly, the technology providers, when we first started the project, the false events were around about 60 odd % in the first month or two. We had believed, according to the technology provider, that the false positives would improve, so you wouldn't get as many over the course of the project. In actual fact, we did. It didn't improve at all. So that gives an overview there. Can you just go to the next slide, please, Jerome? So there was also some other key outcomes. And again, all of this information is in extreme detail in that report. You're quite welcome to download it. There were some speed threshold alerts. That is, we mentioned before the parameters that the technology was set up to indicate an alert, an event at speeds. And whilst all the organisations were set according to technology providers at the consistent speed thresholds, there was a large frequency of exceptions, as in vehicles where alerts were going off that were well under the speed that was indicated, etc. So there was something happening there, whether people had tweaked with the parameters or there was some issues with the technology we're not certain of. The project didn't go into that scope. The frequency of alerts increased over the course of the project. I think that was fairly interesting in itself. I'll be honest, we thought that the frequency of alerts over the course of the project, as drivers, moving towards behaviour change, we thought that the number of alerts would decrease. It actually increased. So there is a trend of more alerts occurring, more events, more alerts. The large number of recategorization of fatigue alerts to distraction across all organisations just simply shows that the technology does not have exclusive parameters associated with those events. But the other key big outcome with this is that that I say to organisations is that if you're putting this in, or if you have it in any vehicle technology, any within your vehicle fleet, don't underestimate the amount of data that you're going to get. And there are going to be challenges associated with policy, with your resourcing and your risk management. You know, the example that I use is if you've got technology in the vehicle monitoring driver behaviour, you can't have events happen on a Monday and you're dealing with it. It's part of someone's job and they're dealing with it on a Friday or something like that. This has to be resourced well. These alerts are going to come in. You know, to give you an example, across organisations that have that put 1 or 2 pieces of technology in their vehicles get 30 to 50 alerts a week with 1 or 2 vehicles. If you've got 100 vehicles, you're going to have a lot of alerts that have to be dealt with. So that needs to be considered in any of the technology that you're going to be put in. Do I think drivers became more reliant on the technology and allowed alerts to control their behaviour? Look, I couldn't really, I couldn't give you a definitive answer on that. The scope of the project did not establish that over a long enough period of time with enough. I'd certainly like a bigger sample, etc., etc. With that, the implications of these results with the when we finish this project, this project was a pilot project that would have funders were prepared to take it further if it showed some good promise. The reality is, at the moment, with the high proportion of false positives, that until those false positive rates come down substantially, they weren't going to fund the further research. The artificial intelligence and things probably needs to go a little bit more advanced, and then we can look at it again. Other than the drivers who quit, do we know if drivers initially opposed to the tech ended up becoming advocates? Looking, the reality is that, again, Michael, that's a bit mixed. Some changed, some didn't. It wasn't, I couldn't say the majority of drivers changed or the majority of drivers didn't. It was horses for courses. So, yeah. Your question there about did the driver alert management lose effectiveness with a look? I think the implications of the false positives are things associated with, and this is where we would have gone with further research had it been funded. So here you are, you've got drivers in a vehicle, you've got a 72%, if we use those figures, false alerts. That's going to get drivers a little bit upset, and that potentially has some implications for the culture in your organisation. So one of the challenges, I think, was also if that's changing the mood and the emotions of the drivers. What we didn't do in the scope of this project, but was the next, if it was gone further, was actually monitor driving and investigate that further with regards to that emotion. And we've got a new project coming on board shortly with some other technology as well. Dave, with the high rate of false positives, were there any trends on poor monitoring equipment? The technology was the same technology in across all the vehicles. I'm not going to say which brand it was, but I have presented these results to the technology providers, and I would hope that these results would spur them to further improvements with the technology. Yes, in the report, we've got some indications of further details about the distraction, but again, it was not so much within the scope of the project. This was about, could the technology identify that in a successful manner? So again, they were things that if we'd have received more funding, we could have gone through and watched all the videos and had a team of people looking at what all those distractions were, and we could have, that's something for the future. Jerome, can you go to the next slide for me, please? So just sort of to finish off, and happy to engage in further chatting, I'll just reiterate the report is publicly available. The funders, the Motor Accident Insurance Commission and Queensland Trucking Association, have agreed that this research is worth disseminating. We didn't want it locked in a filing drawer cabinet, so the 120 odd page report is there. It also has de-identified, of course, but it also has the results for each of the companies in a separate section. So each company have their own results. One of the positives that does come about with this, Jerome, you can do that. Can you put the link in the chat section? Happy for that to occur. So since this project, we've at Griffith University, we have been successful in obtaining a Road Safety Innovation Fund project. What we're going to do in that, and happy to, if you're interested, please contact us. We're looking to, across multiple organisations, recruit a total of up to 250 drivers that would participate in driving a vehicle that you have within your fleet that has some technology, not necessarily this technology, not just an IVMS type technology. And we're going to be fitting people for a few days with some hexoskin technology. So it monitors I'm going to call it the vital signs of the drivers, and overlays that associated with what's happening with the vehicle. So in terms of the questions about, were the people identified with health issues and did they go to doctors, this would do that. This is about, firstly, can we better predict fatigue, but also how does that work with the monitoring of health and well-being. It will also be very interesting to see what's happening to drivers when the vehicle and with their driving operations and they undertake certain tasks or certain events occur. If we think of, things like incidents that occur in near misses with harsh braking events or some such, this technology will help us to investigate. We're in the data collection phase now. So this year we're collecting the data. We have to coordinate. So happy for people to email me if you think you might be interested. We just need to have a chat about what IVMS data or otherwise you have available, the logistics of getting across a company about 10 people to participate, and we can then organise the hexoskin deliveries, and they wear them for 3, 4 or 5 days, whichever we can get them, and then we take them back and dry clean them and all that sort of thing. So that gives it a bit of an overview. Jerome, I think the last slide just provides my contact details, I think. So that's my email address if you're interested in exploring that further or potential participation in the hexoskin project. Happy to chat further about that. And thanks for your questions in the chat. Really good questions, and I'm happy to engage in further discussion if you have a read of the report. There's a bit more detail in it, bearing in mind it had a particular scope. So there was certain things I would like to explore further, but the original scope wasn't that. Yes, we could talk. We were not working with New Zealand Trucking, but certainly open to those opportunities, absolutely.
Awesome, Darren. I'll see if my connection's working well. You've done a fantastic presentation, mate. Thank you so much.
Thanks, Lindy. Yeah. One of the things with this that was good, I believe, again, one of the key benefits of this particular project is it offers a challenge and some good outcomes, in the sense that it wasn't done in a laboratory, so it wasn't as controlled as you'd probably like it to be, that you could do in a laboratory, but at the same time it offered the opportunity to do this in the real world environment. So these companies that participated weren't all just, the same product, the same routes, etc. There were differences. So it was a broad spectrum of the transport and logistics sector. The report does say the type of product. Thank you. Thank you. So are there any more questions? Well, you want to take it from here, Jerome?
Darren, I think my delay is almost 2 minutes. So thank you so much again. Thank you to our audience. If there's any other questions, please throw them in.
Yes, Greg. Look, one of the things I think we need to keep in mind all the time is that the technology is a tool. It's not the answer. It's not the silver bullet. It's not the golden gun. It's a tool. And it has its benefits, but it has its challenges.
Wow, chat, that's fascinating as well. So thank you everyone very much for your session and joining us today. I hope it all worked really, really well. I'm not sure what happened with the technology. We had a perfect run when we did it earlier, earlier last week. So anyway, till next time, please join us.
Thanks everybody for attending and for your interest in your questions.